Hello everyone. Good afternoon to all my students. Welcome to the session, guys. I am your master teacher Kamal Kishor Gupta. Today I will be discussing about unit digits. Now you must be wondering, sir, unit digits? We have studied it in very earlier classes, but don't be worried, guys. I will be discussing how to find the unit digit when we have got very greater powers, right? How to do that. But before we move on, let me tell you guys to this wonder about this wonderful platform here, that is ODA classes, right? We have been awarded as one of the best edtech in this industry, and we have been trusted by millions of parents and students. So what are you waiting for? Just go to the Play Store and download the app right now. Now let me tell you about a wonderful course that I have brought to you guys. This is a very specially curated course because as right now most of you have been promoted to the next class, and when you are promoted to the next class, you are supposed to give your best right from the very first day. For that, you need the best teachers and the best direction. For that, I have brought to you this bridge course. Now, what is this bridge course? You must be wondering. Let me tell you guys. So, this is a bridge course which is having 1 week of duration. In that, you will be getting three maths and three science classes. Live sessions will be there where master teachers will be teaching you live, right? Apart from that, you will be getting a personal teacher. Yes, you heard it right. You will be getting a personal teacher who will be guiding you in all the doubts, all the queries, as many number of times as you want, as many questions as you want, right? So he will be there to guide you every time you have a doubt. You just have to reach him or her, and they will be there and make sure that your doubts are clear, right? So you will be getting a personal teacher. How beautiful it is. And next thing, as after every session you have dedicated your time, you have been focused student, so we will be giving you homework as well so that we can ensure you have got the concept. Once you have got the concept, you have to give a test, right? When we give test, we get confidence. Yes, I have understood the concept, and every time, whenever I will be having that question, I will be able to solve, right? So all these features are there. Apart from that, you will be getting the study material in the form of PDF just right after the session, right? So all these features are there. And if we talk about the course fee, it is 499, but for you guys it has been reduced to 29 rupees only 29 rupees. So what are you waiting for? What are we supposed to do? You are just supposed to go to the link down below, just click on that, and you will be moving to the bridge course. Just click on that, and let me tell you guys, the cost is only 29 rupees. You are going to fall in love with the bridge course. 29 rupees, 1 week program, personal mentor teacher will be there for you guys, right? So now so now let's move on to the next. Okay. So now, guys, before I begin today's session, let me tell you about myself. I am Kamal Kishor Gupta. I am a computer science engineer, and I have been teaching from last 7 years to the students, and I have mentored more than 50,000 students in this journey, right? So I have mentored more than 50,000 students in this journey. That has been quite a beautiful journey for me. So now let's begin today's session. Now that's what we are here for, not for this expression, right? So today I will be telling you that if I have got this wonderful number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, raised to the power 9, 8, 7, 6, 5, 4, 3, 2, 1. So if I ask you what will be the unit digit after this, right? So you will be having this expression, or you can comment down below what will be your expression, right? So this number looks bigger, right? We have to find the unit digit after the multiplication, after I have multiplied these many times this bigger number. So that is very difficult, right? So now, still in confusion, what will you be doing, right? Still, are you having that expression? So now let me tell you, sorry, let me ask you one very simple thing. Just a moment, guys. So let me just ask you a very simple thing. Let's say if I ask you what is 1 raised to the power 3, so will you be able to tell me what is 1 raised to the power 3, guys? Don't you think it is very easier? 1 raised to the power 3. What will be 1 raised to the power 3? You will be saying, sir, what are you asking? Like, we all are matured kids, so we know that that should be 1, right? So you must be saying all of them will be 1, right? After showing you that difficult question, I'm asking a very easy question. But let me tell you, the solution of that question is as easy as this problem, right? So how is it that, let me tell you, we will be discussing that. What are we supposed to do, right? But before, if I tell you the solution directly, let me tell you the concept, a bit about it. How should we solve it and what should be our approach? How to approach for solution for these type of questions. Here, we have to identify few digits, right? As you have just seen, like 1 raised to the power 3, 1 raised to the power 37, we are having the same unit digit. So there are other digits as well. For those, whatever the power be, whether it is million, billion, or trillion, whatever the power be, you will be getting the same number. So same number means same unit digit. I am only saying here same unit digit. So if I say, let's suppose I have got 5 here, right? Let's suppose I have got 5 here, right? So if I have got 5, if I ask you 5 raised to the power 2, 25, unit digit is 5. 5 raised to the power 3, unit digit is 5. 4, again 5. So for 5, whatever the power be, unit digit will always be same. So let's suppose if I take the power of 5 as 1000, right? 1000. The unit digit will still be 5, right? So there are few digits for them, whatever the power you take, unit digit will always be same. So if you write 5 raised to the power 1 trillion, right? 1 trillion, right? That is a very bigger number, 1 trillion. You will again be getting the same digit. So these are the digit which always gets you the same unit digit, whatever the power be, right? So similarly here, if I write for 6, if you just think about 6, right? 6 raised to the power 1, 6. 6 raised to the power 2, 36. 6 raised to the power 3, 216, right? So every time your unit digit will be 6, right? So you don't have to worry about it. So there are few numbers like 0, 1, and I can tell you 5 and 6, right? Please note them down. For 0, 1, 0, 1, 5, and 6. These are the number for which you will always get the same unit digit, right? So you have to remember, if I am having 0, 1, 5, 6 at the unit place, my answer for unit digit will always be same, no matter what the number is, right? So we don't have to worry about them. Now, the story is done for 0, 1, 5, and 6. But is it the same case with other numbers, with other digits? Can we say that are we having the same thing with every other number? No, right? So for that, we have to understand this cyclicity, right? That I have brought to you guys. This cyclicity, what does it mean, right? So let's suppose if we raise the power of 2, if I am raising the power of 2 here, right? So let's suppose if I am saying 2 raised to the power 1, right? So you know that 2 raised to the power 1, right? If we say 2 raised to the power 1, the unit digit is 2. If I say 2 raised to the power 2, right? 2 raised to the power 2, so you will be having the unit digit as 4. If I talk about 2 raised to the power 3, the unit digit is 8. 2 raised to the power 4, 16. It is 16, but the unit digit will be 6, right? I hope it is clear to all of you. Now, if we keep on moving, let's suppose I am having 2 raised to the power 5. So 2 raised to the power 5 is 32. Unit digit is 2. 2 raised to the power 6, 64. Unit digit is 4. 2 raised to the power 7, 128. Unit digit is 8, right? Then again, you are observing that every time I am raising the power, the same unit digits are keep on repeating. The same unit digits are keep on repeating. So if the unit digits are repeating themselves after a certain value, that value is called as cyclicity. So here in the case of 2, here in the case of 2, every fourth digit is repeating, right? So if I am having the power of 2 as 1, 2, 3, 4, or 5, 6, 7, 8, or 9, 10, 11, 12, the unit digits will always be same. So that helps us in calculating the unit digit for even bigger powers, right? So we have to just remember, whenever I am having a multiple of 4 for digit 2, right? Whenever I am having the power in multiple of 4 for the digit 2, my unit digit will always be 6, right? My unit digit will always be 6. So I hope it is clear to all of you. Now, if I talk about 3, right? If we talk about 3, so all of you are aware that if I have the power of 3 as 1, unit digit will be 3. If I talk about the power of 3 as 2, unit digit will be 9. Then 3, 27. So unit digit is 7. Then power 4, unit digit is 1. Now, after that, if you take 3 raised to the power 5, 243, unit digit will again be coming in the same pattern, right? So for 3 as well, we are having the cyclicity as 4, right? So quickly note it down. Please note down the complete table, right? Note down the complete table, and all you have to remember is the cyclicity and the unit digit that you are getting after cyclicity, right? What does it means? Let me tell you with an example, but please note down the table first. So for our here, if I talk about 4, if I talk about 4, 4 raised to the power 1, 4, unit digit is 4. 4 raised to the power 2, 16. So the unit digit is 6. 4 raised to the power 3, 64. Unit digit is 4. Then 4 raised to the power 4, 256, right? So every time I'm having unit digit either as 4 or 6. So here you will be observing that the cyclicity is 2, right? Every second unit digit for power of 4 is coming same, right? So here the cyclicity for 4 will be 2, right? I hope it is clear to all of you. So please make sure you have written the table because I will be solving a question now. So that should be clear to you. What are we doing here and how are we doing it, right? So please make sure you have noted it down. So once you have noted it down, let's note down this as well. So for 5, 6, 7, and 8, we are going to follow the same. We have already discussed 5 and 6. For that, cyclicity is 1, right? Whatever the power be, we will always have the same unit digit. For 7, the cyclicity is 4, right? For 7, the cyclicity is 4. And for 8, if we talk about 8 here, the cyclicity is 4 again here. If I talk about 9, if you talk about 9, the cyclicity is 2, means it keeps on repeating after every second digit, right? Or the second power, you can say. So if I have 9 raised to the power 1, right? Unit digit is 9. 2, unit digit is 1. 3, 9, right? So here the cyclicity will be the cyclicity will be 2, right? I hope it is clear to all of you. Please note it down, and then let's see how to solve these complex problem with very easy method, right? With very easy method. So let's discuss, right? Let's suppose we are having this question. We are having this question, which is 203 raised to the power 3, right? 203 raised to the power 203. Fine. So we are having this question, which is saying 203 raised to the power 203, right? So how we are supposed to solve it? Please remember this formula. Remember this formula, right? This formula simply says, first write down the unit digit, whatever the number be, even if it is 9 digit or 10 digit or 12 digit, whatever the number be, you just have to write down the unit digit. So here in this case, what is the unit digit? Unit digit is 3, right? You have to write the unit digit. So the unit digit in this case is 3. Now we are having a power of 203. So what are we supposed to do? We are supposed to write the power as cyclicity into quotient plus remainder. Do you remember this, guys? Is it clicking in your mind? This is nothing but the same way we used to write divisor into quotient plus remainder, right? This is divisor into quotient plus remainder. Here, your divisor will be cyclicity, right? And here, the quotient is not that important, right? The quotient is not that important. Now you will say, sir, if the quotient is not important and we are going to use long division, right? So that will consume time. But let me tell you that you guys have done something called as finding the remainder, right? So finding the remainder or the divisibility test in your earlier classes, divisibility test for 4. So what is the divisibility test for 4? Last 2 digits, right? So now why I am saying 4? If you guys remember, we have just made the table. Cyclicity of 3 is 4, right? So here we will be taking the 4 as cyclicity. So you have to write 4 here, right? Please make sure you're writing with me. So write 4 here. Then after that, right? Then after that, whatever the quotient is, we don't care. We are not requiring it. So let it be Q. Fine. Just don't write anything. Let it be Q here. Then after that, you have to write remainder. Now you will be saying, sir, without long division, how can I write remainder? So as we have just discussed with the divisibility rule. So what was the divisibility rule for 4? You just have to divide the last two digits, right? So for 203, if I'm having 203, whatever the number is, for 203, just divide last two digits. Whatever the remainder you will get from there, that is the required remainder. So from last two digits, 0, 3, remainder will be 3, right? So you don't have to do long division. And let me tell you, that's how, with the right direction, you can solve these problems very quickly. Otherwise, it will surely consume your time. And in Olympiad, time is the only thing that matters with the efficiency, right? So now here we have got 3 raised to the power 4 into q plus 0, 3, right? So all of you are pro in writing the exponents, right? So what we can do, 3 raised to the power, we can say 4 raised to the power q, right? Into 3 raised to the power 0, 3, right? And if you guys remember, when I'm having 3 raised to the power 4, the unit digit is always 1, right? The unit digit is always 1. So from here, I can say that the unit digit will be 1 raised to the power q, and for 3 raised to the power 0, 3, that will be 27. So the unit digit will be 7, right? We have to write unit digit only, nothing else. Every time, whenever you are solving, you just have to write unit digit. In case you are getting 2 digits or 3 digits, make sure you are writing unit digit and forget about everything else, right? You just have to focus on that. So now from here, 1 raised to the power q, whatever the number be, we will always get the same unit digit, right? 1 into 7, right? So from here, my answer will be 7. So how much time will you take if you apply the concept in this way, right? Just write your answer in the comment below, that how much time will you take if you're practicing properly and applying this concept. I think it can be solved in 30 seconds. And if you are taking more time in that, you just need to practice a bit more. But with this method, 30 seconds are enough, right? So I hope all of you have got this concept. I hope all of you have understood well enough to solve these questions, right? So make sure you are commenting down below that whether you find it useful or not, right? So that's all from my side. But before we leave, about the so let me tell you guys about the app as well, right? The system that we have discussed. You can note down this question as homework, right? You can note down this question as homework. And again, guys, let me remind you that you can download our app, right? Okay. So let me remind you guys that you can download our app right away and subscribe to the bridge course that is having the link down below, right? As we have discussed. So thank you so much. We'll see you soon.